Hi everybody, welcome to the class number 4 of the track number 4, and finally we're gonna show again in this video how you can use the previously videos developments to apply some concepts of artificial intelligence techniques on the container port logistics. We're gonna show how we can produce finally some operators, how we can select some possible solutions using a function, and we're gonna develop this function. If you didn't see the previously class, it will appear as a class somewhere. And my name is Anibal Azevedo. I don't know if you saw the previously videos. It's very important. And but if you didn't saw it, didn't see the videos, it's not. It's okay because we have all the code in the description of this video. You can try yourself discovering the code. And let's see what we have in the description of this video. Here is the code. So we already saved and loaded all this code that we developed in previously tracks and previously class of this track. And finally, what we got in the previously class, we got the scores. Okay, so each individual in the genetic algorithm had been evaluated. So it means that we have a container ship that made a travel through ports, and we evaluate the number of containers that will be related with each solution that we propose for the container ship. So now, what we're gonna do, we're gonna build finally the selection function. So to make this, we're gonna need to understand what this radiant. Radiant is the we defined in this. Radiant is from this. It's a method from this model numpy.random, and if you need it, okay. So rand how this work, this function, it will rand int. Okay, now it's okay. So if you put 0 and len pop is just a list with some possible solutions, okay? So if we do this, we got, for example, uh, length. This is the length of the this. Let's do this. It's just the number of individuals that we have in population. So by doing this command, we can produce numbers, which random numbers, two random numbers, which range will be from 0 until number 3, okay? So it can be 0, 1, or 0, 2, or 1 and 2. These are the random possibilities that we can get by applying this command. So imagine now that we got this command, and instead of use this rand int, just use this, okay? So you can produce 1, 1, always produce 1, okay? Or maybe 2, 0, 1, 2, and 0. So if we do this, imagine now that we have selection. So this is the index that we will select at handle. But we also can select some individual by using the information of this number of movements, the individual scores. So remember that we defined in the previous class the scores, which means the number of movements that it will be done by applying the combination of rules, reports. Okay, so this is the So here we have a kind of loop, and in this loop, we're gonna do a comparison between the individual inside uh, this random int with, and the individual, of course, selection. So what is the great question here? We selected some individual at random, and then this individual selected random, we're gonna compare with all the individuals in the population that we got, and we're gonna compare their scores. If the score of someone is better than the individual that we selected at random, then we said that the individual that we should select, the individual index that should be selected will be the index of the individual that has a better score. Okay, so this is the basic thing that we should use to select the best individual in a population, to select the individual which the score is better, is the best in the population. So let's see this in this context. Obviously, we don't have this because all individuals in this population has the same the same score, but in a very large number of combination of rules on a higher number of individuals, this can be very different. So let's just try to understand this and see that what happens also in this context of every individual has the same score. So here we selected at a handle the individual number 2, which index is 2, the third individual of this population. Okay, so this individual has the rules, these rules. Okay, and finally we got this number of movements. So no surprise on this, no surprising on doing this. What is important now is that we should transform this into a function. So to make this as a function, it's not difficult, but we have to think about what should pass to this function. So to transform this into a function, let's start another cell here. We don't need this. Okay. So the right code will be something like that. So we need that to define a function. And then we have scores. We're gonna pass these scores. Since this is not information that we compute in this function, okay? There is a function that will give to us these scores. So finally, we have this, and we have to return. Don't forget to return the individual that we selected. This is the most important thing, not the individual index. This is not important. Selection. Okay, you can say that, oh, this population is not given here. So you also need to pass this information. But we can solve this if you define this function inside a class, or define this function as a method, and this information is stored as a field of a class. So this could be it will be not necessary to pass this. Okay, so we can make this function more simple. I know that it means that this information is already available, or it has a global scope, but it's not a problem because when we connect all codes, all functions inside a class, this will be more clear. So what is important here, when we made this function, when we defined this function, this will be more very easy to call this function and to evaluate or to get the best individual. For example, we can get the select individual by doing just this selection, selection, scores for in. So we can in range number, the length of the population. You can set this length of population or number of population. You can also do this. So let's print the selected. So as you can see in one line, we can call this function for all individuals, and we get what's interesting here. We apply this, and we this give us a new population. So what is the interesting thing here? We call this many times for the population, the range of population, and this maybe selected at a random the best individuals in the population and created a new population with the best individuals. But as you can see here, this is not the same population that we got at the beginning. See here, I have this population, and we can apply many times this, and this will got for us a new population with individuals with a very high score. Okay, a very good individuals at their score. So this is very interesting and important for your genetic algorithm. So okay, so finally we get this method that's very important. What is missing? We need a crossover method that we will create in the next class, and a mutation method, which will be in the another class. So with this, all these components, we can explain the genetic algorithm class, and so some more patient will be necessary just for the next class and another one to explain the components that will be necessary for the genetic curriculum. Thank you for your attention. I hope you find this video interesting and useful for you, and see you in the next video. Bye.